So box plots can be particularly helpful when trying to compare two different data sets. So in this case, we have two different fast food restaurants, two different stores, and let's see what we can deduce from these box plots. So first thing we might look at is the median, and remember the score at the middle bar there is the median. And so store 2 has a smaller median, which means that the that half, remember, the median represents the score that divides the data in half, and so 50% of the time you're served in under 2.3 minutes here, and 50% of the time you're served in under 2.1 minutes there. So one could argue that on some measure of average, remember average is a not specific term, but by some measure of average, store 2 seems to serve a little bit faster. However, we also can notice that this range of values, because remember this represents 50% of the data as well, because these quartiles are dividing the data up into quarters. So 50% of the time here, you're served between 1.8 and 2.9 minutes. Here, 50% of the time, you're served between 1.1 and 5.7 minutes. And so the second store is a lot less consistent in the time, and we can also see that in this very large range. The first store seems to be more consistent in its delivery. In fact, 75% of people are served within 2.9 minutes. Only these unlucky 25% here were served in a longer time. So if you're feeling really lucky, you might try store 2, because you might get lucky and get served really quickly, faster than you might in store 1. But certainly, if you just can't spare a large amount of time, then store 1 might still be your better bet, since they seem to be a little more consistent in serving quickly. So let's look at another case. So the box plot here shows the birth weight of infants with severe idiopathic respiratory distress syndrome, or SIRDS. The box plot is separated to show the birth weight of infants who survived versus those that did not. And so what can we deduce from this, from these box plots? So we can tell that the birth weights of infants that died appears overall to be smaller than the birth weight of the infants that survived. In fact, we can see that the median birth weight of those that survived is about the same as the quartile 3 of birth weight of those that died. So this means that, for example, here, this is 25% of infants that survived. 25% of infants that survived were heavier than all of the infants that died. Likewise, notice that the quartile 1 here is bigger than the median here. Remember, quartile 1, this is 25% of the data, this is 75% of the data, so 75% of infants who survived had a higher birth weight than the median birth weight of an infant that died. So this gives us a quick, admittedly informal way to look at data and get some idea what's going on.